Okay, Chapter 3 talks about relative thinking and measurement. So if you look at the opening activity on page 39, you see student strategies looking at trees and how they grow over time. So we're going to have a similar discussion that deals with snakes in our example. But there are two ways of thinking about these things. So things change. They change in absolute terms, and they change in relative terms. So relative terms means it changes with respect to where it is right now and then where it's going to be in the future. Absolute, you just subtract, the new size minus the old size, and that's the absolute change. Okay, so let's get into the notes. So two perspectives on change, as I said, absolute and relative. So we're going to do the snake problem. So the snake problem says the following. So Slither is currently 4 feet and Slim is 5 feet. Slither will reach 7 feet in 2 years, while Slim will reach 8 feet during the same time period. So if you think of it just in terms of absolute, which is what the younger kids will, you're going to see that both snakes will add 3 feet in that 2-year time period. But if you think at a little more advanced level, in some respects, and think relatively, so if you think relative to where they are now, Slither's going to grow 3/4 of her current length, while Slim will grow 3/5 of her current length. So if we change those to percentages, we can see that 3/4 is 75% and 3/5 is 60%. But what the kids probably will be thinking about is they both have the same numerator, and since the denominator is bigger in the Slim case, then that number has to be smaller. Okay, that's going to be the initial reasoning. So anyway, proportionally speaking, Slither will grow proportionally by more than Slim. So relative thinking is called multiplicative thinking, and absolute thinking is called additive thinking. And these two forms of thinking come at a problem from different directions. No one answer is more right than the other. So relative thinking is going to be more important to us in the study of fractions because it helps us to understand certain things. So here are the bullet points that we want to focus on. The relationship between the size of pieces and the number of pieces, the need to compare fractions relative to the same unit, the meaning of a fractional number, the size of a fractional number, and the relationship between equivalent fractions. Okay, so relative thinking ties all of those bullet points together. When teaching elementary students to think in terms of multiplicative with proportional reasoning, remember their go-to method will be addition. So you're going to have them kind of think in a different way. So in order to help them graduate to relative thinking, you've got to work on your verbiage. Sometimes if our language is such that we say, if we don't change our words, we're not going to help guide them down the path. So if we always say which is larger, that can pertain to an addition problem like length or a multiplication problem like area. So you've got to be more precise. So examples of questions that require absolute or additive thinking. Who has more cookies? How many do they have together? Okay, so that's going to be an absolute answer. And they're going to be able to use addition and subtraction to get to it. Examples of questions that require relative or multiplicative thinking. What part of a dozen cookies does Clint have? And what % of each boy's cookies are chocolate chip? Okay, that's more advanced thinking. Pizza examples, you've got to be careful about your wording. If you say each boy ate 2 slices of pizza, how many slices remain to be eaten, you'll get an absolute answer. It'll be gotten from either addition or subtraction. Once the boys ate their 2 slices each, what fraction of the pizza remained? That's going to give you a relative answer. So there are two meanings for the word more, and you want to be aware of that. So class discussions regarding problems like the 2 families, so each had girls that they presented in our textbook. that'll open the door to the introduction of relative perspectives, because someone's bound to kind of view it from the point of view of, well, they have the same number of girls, but the size family is different. So you can kind of naturally guide your class towards this thinking. Terms such as larger portion, larger percentage will also kind of switch the thinking from being, purely addition and absolute, and guide it towards multiplicative. So that's what you want to be doing. And on page 45, there's some good reasoning analysis involving apple drinks. And this is good to review because this is kind of the first step towards a mixture problem, and they're always very difficult at first. Okay, measurement is really important. Concept of measurements play a large role in understanding both rational numbers and in multiplicative reasoning. So a fraction measures the multiplicative relationship a part has to a whole to which it belongs. So for example, if you say he ate 1/8 of the pizza, that gives you that perspective. A ratio also measures relative magnitude. The pool covers 2/3 of the fenced area. A rate such as speed is a quantification of motion. He drove 25 miles per hour. So all these measurements, they're a little bit different, but they all involve fractions, so we'll keep going. Okay, a quotient is a measure of how much one person receives when m people share n objects. An operator is a measure of some change in a quantity from a prior state. So we're going to have a whole chapter on fractions as operators. As a measure, a rational number directly quantifies a quality, such as the length or the area. So it's helpful to think of a measurement as a ratio. If you are 6 feet tall, you are comparing your height to 1 foot, and the ratio is 6 feet to 1 foot. So you don't usually think of your height as a ratio, but if you do, it kind of gives you a little more of an insight into how we can use these in our normal conversation with our students. Okay, measurement has 3 main principles that are going to be discussed in our textbook. Okay, the first principle is the compensatory principle, and that is that the smaller the unit of measure, the more of those units you need to measure something. And conversely, the larger the unit of measures you are using, the fewer of them it will take to quantify the same amount. Okay, so that's the compensatory principle. The approximation principle is that a measurement is always approximate. So you're always going to have some degree of accuracy, but it's still going to be approximate. And the third one is the recursive partitioning principle. So in math, partitioning is the act of dividing a set or a unit into non-overlapping and non-empty parts. When using the word partitioning in reference to fractions and measurements, we further require that the subparts be of equal size. Okay, so we'll do a lot of activities on a number line to show that. So the example they come up with is the gas gauge example. So if your gas gauge needle falls exactly between a half and a fourth, how much gas do you have in your tank? So if here's a half, here's a fourth on a number line, how much gas do you have in your tank? And if it's exactly halfway between, what are we going to do? We're going to do some partitioning. So the key is going to be common denominators. If you write 1/2 as 4/8 and you write 1/4 as 2/8, what's directly in between those two? That clearly is going to be 3/8, and we have just partitioned to get the number in between. And our textbook also introduces us to the idea of measuring more abstract qualities. So they do that with their mixture problem. So on page 51, there's the orange drink problem. So you're measuring an abstract concept, how orange this tastes. So all else equal, if you have more cans of OJ than you have cans of water, the more orangey it will taste. So that's going to be the key. And so therefore the key is actually the ratio. Okay, so other strategies dealing with measurement, a unit rate tells how many units of one type of quantity correspond to 1 unit of another type of quantity. So the quantities are different: miles per hour, price per gallon, price per item. Okay, 1 is implied in each of these, so I put that in parens just to remind us that that is the case. Okay, we have one more page of some other strategies. Okay, you can use double counting or double matching. So 5 nickels is equivalent to 1/4. 10 nickels is equivalent to 2/4. 15 nickels is equivalent to 3/4. Okay, so you're matching ideas. So it's kind of abstract reasoning. And then the mixture comparison is definitely something that we're going to be building towards. So if you're looking at picture 1 and picture 2, which one has the stronger blueberry taste? So I'm looking at that, and one strategy is to look at picture 2 and say, what if I subtract that much? Could I possibly do that? So I can, and look, I'm left with more blueberries over 1 water. So therefore, picture 1 will taste more blueberry than will picture 2. Okay? So there'll be a lot of discussions about this. So you're now ready to go through the activities and look at your answers in more, and then look at the problems I have set aside in the problem set. And then we'll be able to discuss this next class.